Tesla just launched a phone that eliminates carriers, survives 6.5-foot drops onto concrete, and connects through satellites covering 98% of U.S. landmass. While Apple users pay $150 monthly plus $500 screen repairs, the Pi phone delivers lifetime free Starlink internet and a modular display that refuses to shatter. Real tests show 95% drop survival versus Apple's 60%. The engineering is proven. The price is real. But here's what matters. Can Apple's entire business model survive when monthly bills just became optional? Let's address what everyone's thinking. How does a $175 phone deliver unlimited internet without monthly bills? The answer isn't magic. It's direct-to-device Starlink satellites operating at 100 megabits per second. Downlink across 98% of U.S. landmass. No SIM card, no carrier, no contracts. Traditional cellular networks reach only 70% coverage in rural Texas. Apple's entire ecosystem depends on ground towers that cost you $150 monthly and still fail in dead zones. Tesla bypassed that system entirely. The Pi phone connects to 6,000 satellites using a 2-inch phased array antenna, drawing under 2 watts of power. What does this mean for you? Drive through Nevada deserts, hike California redwood forests, or sit in a New York subway 100 feet underground? Your connection holds at 75% to 99.9% reliability. Real-world tests show browsing speeds between 50 and 150 megabits per second with zero data caps. Apple users experience 30% downtime during peak hours in dense areas. The Pi phone maintains 95% uptime because it's not competing for tower bandwidth with millions of other devices. The satellite beamforming antennas adjust dynamically to vehicle speeds up to 120 miles per hour, resulting in 40% fewer drop calls than iPhones during Texas drive tests. Here's where the math gets serious. Over 10 years, avoiding carrier fees saves you $12,000. Florida alone could see 2 million subscribers abandon cable services averaging $150 monthly because the Pi phone streams 500-plus channels through satellite multicast with under 20 milliseconds latency. That's $3.6 billion shifting away from traditional telecoms in one state. Authentication happens through laser interlink constellation using quantum secure encryption, making setup 80% faster than iPhone eSIM activation. No waiting for carrier approval, no credit checks, no annual contract negotiations. You connect directly to satellites that don't care about your payment history or geographic location. Indoor coverage maintains signal strength above minus 100 decibel milliwatts, delivering 90% reliability inside Florida high-rises without signal boosters. Apple users still face indoor dead zones affecting 25% of residents. But does this scale nationally? Analysts project 10 million units sold in California within 2 years would trigger a 30% decline in iPhone upgrade demand. Apple currently holds 55% U.S. market share. A 20% reduction translates to $50 billion in annual telecom revenue at risk. When you remove the need for carriers entirely, the entire pricing structure collapses. The projected global reduction in telecom bills reaches $50 billion annually when this technology scales across major markets. So here's the question nobody's asking. If satellite internet performs better than cellular and costs nothing monthly, why would anyone keep paying AT&T, Verizon, or T-Mobile? What happens when 50 million Americans realize they've been overpaying for inferior service? The entire carrier model depends on you believing there's no alternative. Tesla just proved otherwise with hardware you can hold in your hand. This connectivity advantage sets the foundation, but unlimited internet means nothing if your screen shatters the first time you drop the device. That's where Tesla's material engineering creates a gap Apple can't close with marketing alone. Drop your iPhone from 6 feet. There's a 40% chance the screen shatters. Drop the Pi phone from 6.5 feet onto concrete. It survives 95% of the time. This isn't marketing. It's measurable engineering using modular architecture and nanoparticle-infused glass rated at 1.5 gigapascal hardness. Here's how it works. Instead of one brittle glass slab, Tesla engineered separate display layers, touch layers, and protective coatings that magnetically lock together. When impact occurs, energy spreads across module seams rather than concentrating at a single fracture point. Fall simulations show catastrophic failure. Probability drops from 80% to under 20% across common drop angles. The physics is straightforward. Distributed impact absorption prevents the concentrated stress that creates spiderweb cracks across traditional screens. The genius isn't just strength, it's repairability. Each layer swaps out in under 5 minutes for about $20. Compare that to Apple's sealed displays requiring $500 plus full screen replacements. One damaged layer no longer destroys the entire phone. For seniors on fixed budgets or families with kids who drop phones constantly, this changes the total cost of ownership dramatically. Modular design cuts e-waste by 40% compared to Apple's sealed architecture, where minor damage forces complete screen disposal. The material science goes deeper. High mobility oxide semiconductors deliver 50 square centimeters per volt-second electron mobility, enabling 120 Hz refresh rates while consuming 30% less power than Apple's OLED panels. You get smoother scrolling, cooler operating temperatures, and 2 extra hours of daily battery life without increasing battery size. Peak brightness hits 2000 nits for clear outdoor visibility in direct Texas sunlight. Color accuracy stays below delta E1, making streaming 25% more vivid while reducing eye strain by 35% during long reading sessions. For older viewers dealing with vision fatigue, this isn't a minor spec improvement. It's a daily quality of life change. Thermal resistance pushes to 300 degrees Fahrenheit. That matters because Texas asphalt regularly exposes phones to 160 degrees Fahrenheit environments where Apple screens begin warping at 175 degrees Fahrenheit, leading to $300 annual repair costs for heavy users. Tesla's display completely avoids thermal deformation failures. The oxide layers maintain structural integrity even when your phone sits on a car dashboard in Arizona summer heat that would damage conventional displays. The self-healing micro-coating automatically fills shallow scratches with 80% effectiveness, so surface wear becomes invisible. You won't notice most minor abrasions that would permanently mark an iPhone screen. Wider tactile bezels make the phone easier to grip for users with tremors or weakened hand strength. High contrast modes operate at low drive voltage, keeping medication reminders and emergency contacts readable all day while consuming minimal battery. These aren't luxury features. They're accessibility considerations built into core engineering. Analysts expect 15% of Apple's repair market to shift toward third-party modular services because users can now fix phones themselves instead of paying Apple's monopoly pricing. When replacement costs drop from $500 to $20, the economic incentive for DIY repair becomes overwhelming. But here's the uncomfortable truth. Apple profits enormously from fragile screens and expensive repairs. Their entire service revenue model depends on devices breaking and customers paying to fix them. What happens to that $20 billion annual service revenue when screens stop shattering? This durability creates immediate value for everyday users. But the engineering philosophy behind these choices reveals something more significant. Tesla didn't just make a tougher phone. They designed for conditions where failure isn't an option. That approach becomes crystal clear when you examine why these specifications exist in the first place. This is where Tesla's strategy separates from every other phone manufacturer. They didn't design for Earth and then claim Mars compatibility as marketing. They engineered for Mars requirements first, and those extreme specifications immediately solve Earth problems everyone else ignores. Communication in Mars environments requires satellite-first architecture because there are no cell towers. The Pi phone pairs directly with Starship's onboard Starlink relays, enabling 10 megabits per second data transfers from Mars orbit with 20-minute latency through laser-linked satellites. One system supports 100 colonists without dishes, towers, or ground repeaters. Apple's carrier-dependent architecture can't even begin to function beyond Earth's atmosphere. That technical limitation isn't theoretical. It's fundamental to how their entire network operates. Radiation shielding becomes critical on Mars, where cosmic rays and solar flares destroy standard electronics in months. The fiberglass display combined with high mobility oxide layers absorbs 90% of high-energy radiation, extending device life to 5 years in Martian conditions. iPhones degrade in 2 years under normal Earth use, but here's what matters for Americans. That same radiation resistance translates to extreme durability during solar storms, electromagnetic pulses, or disaster scenarios where standard phones fail completely. When infrastructure gets damaged, radiation-hardened components keep functioning. Power efficiency designed for weak Martian sunlight and weeks-long dust storms means the Pi phone runs on 40% less energy during low-light operation. Connect it to small solar cells and it operates indefinitely, consuming just 2 kilowatt-hours daily. For seniors during Florida hurricanes or Texas blackouts, this engineering means emergency features stay active when everything else goes dark. The same power discipline that keeps colonists connected during Martian dust storms keeps families connected during Earth emergencies. The modular repair system that makes Mars residents self-sufficient also makes disaster-zone Americans resilient. When infrastructure collapses, a $20 module swap keeps you connected, while iPhone users wait weeks for Apple Store repairs that may not even be available. You're not dependent on supply chains or authorized service centers. The phone becomes repairable with basic tools and replacement parts you can stockpile. Tesla's positioning here is calculated. They're capturing 10% of the $50 billion global space technology device market, while simultaneously disrupting Earth's $1.4 trillion smartphone industry. Apple can't move into space tech because their ecosystem requires Earth-based infrastructure. Tesla's ecosystem requires only physics, satellites, and resilience. One company is limited by geography. The other is limited only by orbital mechanics. The real genius isn't claiming this phone goes to Mars. It's recognizing that designing for Mars-level challenges, radiation resistance, satellite communication, modular repairs, extreme power discipline, automatically creates the most reliable Earth phone ever built. For disabled veterans, low-income families, or anyone needing dependability over luxury features, that engineering philosophy delivers more value than any iPhone ever could. When your priorities are communication reliability and long-term affordability rather than status symbols, the choice becomes obvious. So here's the final question. When a phone built for Mars outperforms Earth phones in every reliability metric while costing nothing monthly, how does Apple compete? Do they lower prices and admit they've been overcharging for years? Or do they double down on luxury branding while losing the mass market to superior engineering at 1/10 the cost? This isn't a phone upgrade. It's a complete system reset. Apple spent 15 years training you to accept expensive fragility and monthly bills. Tesla just proved neither was ever necessary. The question from the beginning wasn't whether Apple could match this technology. It was whether their entire business model survives when monthly payments become optional and screens stop shattering. The answer is already playing out. When 10 million Californians realize they're paying $1,800 annually for inferior service, market dynamics shift fast. When seniors discover $20 repairs instead of $500 Apple fees, loyalty evaporates. This is how disruption actually happens. Not through marketing, but through engineering that makes the old way obsolete. And this is just the beginning. As Starlink expands to 12,000 satellites and modular architecture becomes standard, the smartphone market splits into two paths: devices built for Earth's outdated infrastructure and devices built for anywhere humans go next. If this breakdown showed you what mainstream tech coverage missed, hit that like button and subscribe to Tesla Zone. Turn on notifications so you're here when the Pi phone officially launches and triggers the biggest market shift in tech history. What happens when Tesla scales this to 50 million units? Does Apple lower prices or lose the mass market entirely? Drop your prediction in the comments. A for Apple adapts, B for Tesla dominates. This is Tesla Zone. We don't just report tech news, we show you the engineering that changes everything.